Hello class, so today's section we'll be walking through the problem separate by length. So, as specified by our spec, we are given a stack of strings as an integer n, and we are tasked by a function that rearranges the elements inside the stack, such that those with length less than n appears at the bottom of the stack, and those that has length larger than or equal to n appears at the top of the stack. So, let's walk through an example to better understand our spec. So we are given this stack right here where high is at the bottom and bi is at the top. And n is equal to 4. So after our function is called, high, hey, and bi appears at the bottom of the stack because high, hey, and bi has length less than 4. While hello and howdy, on the other hand, has length larger than 4. So it appears at the top of the stack. So now that we understand our problem better, by walking through the example, we should break the problem down and pseudocode before we implement the code. So, as discussed in class, the stack has a first in, first out structure where elements are added and removed at the top of the stack. So, because of this, we're very restricted in how we're able to access the elements. Instead, we are given an auxiliary queue, so we should make use of this. We should transfer all the elements in the stack into the queue because it provides more flexibility because of the queues last in, first out structure, where we're able to remove elements from the front of the queue and then add the elements at the back of the queue. So transfer all the elements into the queue. Afterwards, we want to iterate the queue by removing the elements by the first element and checking whether or not if that element matches our condition of it being the length less than n. If it's less than n, then we want to add to the stack so that the elements that have length less than n appears at the bottom. Afterwards, after we finish iterating through the queue, we have the remaining elements inside the queue are those that have length larger than or equal to n. So we want to add the remaining elements. Okay, now that we have done pseudocode, we should fill in the blanks. So the first thing that we want to do is to initialize our queue. Queue string queue new equal new this. Okay. After we have initialized our queue, we would want to transfer the elements into the queue. So we are provided with the s to q method. So s to q. After we have transferred all the elements into the queue, we want to get the size of the queue. A common pitfall that students may encounter is that they forget to get the size of the queue and just iterate through the queue by getting the queue size right here. The reason why this is problematic is because we are removing the elements and adding it back into the queue if it doesn't match the condition. And because the size is varying, it would be really bad because there might be cases where it solves way too early. So we want to get the size of the queue. So queue dot size. And then we want to initialize our for loop statement. So for int I is equal to 0, I is of the size I plus plus. So then we would want to get the first element inside the queue. So if so we can use the syntax to get the first element. So queue dot remove. Okay. And then our if condition here is we check whether or not the length of the word is less than n. So if word dot length is less than n. If it's less than n, then add it to the stack. So s dot push word. If it's not less than n, we would want to add it back into the queue to preserve the elements. So queue dot add word. After we have iterated through the entire queue, the remaining elements are those that have length larger than or equal to n, so we want to add the remaining elements. So we use the method queue to add the remaining elements. Okay, that's it.